Okay. So this, I think that the name of the chapter is Topics in Analytic Geometry. The most of it, probably what you'll remember out of, it's what's the conic sections, or conics. And the conic sections, we'll see, but we start with parabolas. I would say that it's probably about the same difficulty as the chapter that you just finished, just to give you an idea. So by conic sections, or conics for short, right, those are the shapes that you would get if you passed a plane, right, a flat surface, through what's called a double napped cone. Right, so you can see this cone is, they're like the ice cream cones where the points touch. Right. So if the plane is exactly parallel to the base of the cones, it's a circle. Right, that's a circle. If it's tilted just a little bit, it's an ellipse, meaning it'll be longer in one direction than the other. If it's tilted so that it's parallel with the side of the cone, that's a parabola. And if it's straight up and down, then that will be two shapes that kind of look like parabolas, but you put them together, that's a hyperbola. I mean, obviously, we've done circles. We talk about a little bit, but not much. We've done parabolas, right? In some context, we have looked at parabolas before. Ellipses are new. Actually, hyperbolas are not new. You've done hyperbolas before. That's the graph of an inverse variation. Y equals 1 over x. Right? If you do something like that, you've got, right, one piece there and one piece there. And that is a hyperbola. So you've actually seen that before. Right, this is taken right from the book. Okay, now there's actually three cases where you pass a plane through these shapes and you do not get a conic section. I mean, imagine if you pass a plane right through the point where they come together, then what would the intersection be? The point. Or if the plane was exactly in this position here, then it would be just tracing out a line. Or if it was straight up and down in the middle of the two cones, it would be tracing out these two lines. None of those are conic sections. Those are called degenerative cases that they only mention at the very beginning of this section, 10.2. But some of their problems do lead to this. It's like if you come up with, you're solving it, and you end up with something where you get a straight line, it's not that you're wrong. It could be that it's one of these degenerative cases. There's not many, but most years I accidentally assign one, and that ends up being the thing. It comes up with a kind of a weird solution. Okay. So just to mention circles, the only reason we do circles at all right now is just at the very end when we've done the other three shapes, then we are asked to be able to look at an equation that is in this form, right? Whereas you've got an x squared term and a y squared term, and an x to the first term and a y to the first term, and a constant, and it all equals 0. That's a general second degree equation. And just by looking at it, recognize what shape is it. Right? So the standard form of a circle is this: x minus h squared plus y minus k squared equals r squared, the radius. Right? The first example is exactly in that form. So you know that the center of the circle is 1, -2, and the radius is 3. Now, the next one, which is not in that form, is still a circle, right? And you recognize it because it's 1x squared and 1y squared. Ultimately, we could complete the square and make it look like that. But even if it's not 1x squared and 1y squared, as long as the coefficients of the x squared and y squared are the same, we recognize that as a circle. Right? That's the only one of the four shapes that that's true for. So as long as these two are the same, and equals means circle. Now, when we get to a parabola, what do we know about the squared terms for a parabola? What is the parabola? If you had to define it, a parabola is the shape of a quadratic. Give me an example of a quadratic. Y equals x squared. There you go, right? How many squared terms? 1. That's how you recognize a parabola. If it's in this form, you only have one squared term. Right? Circle is they're equal. Parabola is there's only one of them. I mean, there's a fair amount of questions. That's all you have to know. If you recognize that pattern, just say it. Now, if you wanted to see any more about that, it's actually in the very first part of the book, the page 17. It's not part of this chapter at all. But only when we get to that part about, classifying. Then they expect that we understand this part of it only. Right, now, a parabola, besides being the graph of a quadratic function, which it is, when we studied this stuff in chapter 2, right, that was the standard form for a quadratic, and the shape of the graph was a quadratic function. Right? A quadratic function means that it has the shape of a parabola and it's a function. And what does it mean to say that it's a function? What is a function? Okay. And if you're looking at the graph, what test does it pass? A vertical line test, right? So these were always, since we were dealing with quadratic functions, the graphs were always something like this or this. They either opened up or down. And the kind of things that we did with that, besides graphing, axis of symmetry, things like that, maximum and minimum, right? The minimum, the maximum, which is the vertex. Okay, in this chapter, we're not just interested in functions. We're actually going to look at parabolas that open to the right or to the left. And those are not functions anymore, but we still study them. That's what we're doing in this chapter. Right? Not just these, but these and these. And we're not so much interested in max and min, although that is part of what they're doing. I think I'm going to just avoid that because we did that already. And then this is the new definition for a parabola, not just the graph of a quadratic. It's the set of all points that are equidistant from a point and a line. Okay, now what does the word equidistant probably mean? Equal distance, right? And the point, these are vocabulary words, right? The point is called the focus, and the line is called the directrix. So we'll see on the next slides what that means. Okay, slow me down if I'm. So just to look at the graphs first, since we just got off of the definitions, right? The parabola is the set of all points that are equidistant from a point, which is the focus, which is inside the parabola, and a line called the directrix, which is outside. So for every point on this parabola, if I find the distance, which means the shortest distance, to that line and to that point, it's equal. Right, so this distance equals this distance. And that's true for every point on that line. So whether it opens up or down, right? These I would call, the orientation is vertical because it's opening up or down. And the standard equation for a vertical, they're saying the vertical axis here is that. Now, in terms of parabolas, we've already seen the HK. What does the HK represent? The vertex right there. So there's the H and there's the K. And the X and the Y are variables. You're always going to have those in your equation or else you wouldn't have a shape. Okay. The one thing that we have not seen so far is this letter P, right? And the P is called the directed distance, We don't really use that phrase, that term very much. But on the graph, the P is this from the distance from the vertex to the focus, or from the vertex to the directrix, which have to be the same, right, is P. Right? That's P. That's P. Between the vertex and the focus. That's what it's saying right there. Right? When the parabola opens up, P is positive. If the parabola opens down, P is negative. Now notice in the equation, we're used to quadratic functions, right? In the terms of what we did then, the parent function was y equals x squared. So if you notice here, the x squared is actually on the left, the way they've written it, and the y to the first is here. But it is solved for the squared term. Everything you've got to have the x minus h squared by itself on this side, and then everything else goes on the other side. Okay, that's a lot of. Now, if we do in the horizontal axis or orientation, now they're opening to the right or to the left. This is the equation. Right, so now the squared term is the y, and the x is to the first power. So this is x equals y squared. This was y equals x squared, right? Y equals x squared should be familiar to you when you see it. You go, okay, that's the vertical one. When it's x equals y squared, you say that's horizontal, because that's the one we didn't do before, right? It's still y minus k and x minus h. You don't switch them. They're always associated with the letters. They still represent the vertex, and there's still this directed distance, which is the P, and in this case, the P is from the vertex to the focus, from the vertex to the focus. If it opens to the right, P is positive. If it opens to the left, P is negative. Again, focus is inside, directrix is outside. Inside, outside. What does that say? Okay. So find the standard equation of a parabola. For this one, find the standard equation. The vertex is at the origin, and the focus is at the point 2, 0. Now, I would always say every time, draw graph, right? Try to make sense out of it once you've looked at the graph. Don't try to just start throwing things into the equation if you haven't looked at it. Right? If I sketch a graph, right, the vertex is at the origin, so it's here, right? That's the HK. And the focus is at 2, 0, which is here. So this is the focus, and this is the HK. That's bad. So just by looking at that, you should be able to tell me what direction is this thing opening up. Where is it, sir? To the right, right? You know that the focus is inside this thing, and the vertex is there. So we know that it's doing this kind of thing. So that tells me which one of the standard equations to use, right? Because there was 2 of them. I got to use the one that was for horizontal. So this will be y minus k squared equals 4p x minus h. Okay, so what do I need to fill into that? No. I have to fill in for the h and the k and the p. Okay, well, the hk is the vertex. What's the vertex? It's 0, 0, so I know that, right? And what is the p? On this picture, what is p? P is this distance right there. And it's opening to the right, so P is positive 2. That's everything you need to fill in to that equation. Right? y minus 0 squared is y squared. Just a second. I should take 2 steps. Y minus 0 squared equals 4 times 2x minus 0. So y squared equals 8x. Right, that's the standard form. It should be solved for the squared term. Everything else is on the other side. Okay, find the focus of the parabola. Okay, this leads us to the fact that for most of what we do in this first part of the chapter, you're going to have to complete the square. Okay, that is just part of it. You get problems like this, it's rarely given to you already in the standard form. You have to be able to do that part. So in this case, right, so start by completing the square in order to put it into the standard form. And from that, you'll be able to find the focus. Right? So put in standard form by completing the square. And then find the focus. Okay, if you don't remember, which you probably don't, when you complete the square, that means the squared term is x, right? So this is definitely going to be a parabola. It's y equals x squared. It's negative. It's going to open down. So we got the p will be negative. But I need it to be x minus something or x plus something squared. So in order to do that, I need to complete the square. Now, if there's a coefficient on the x squared, you've got to factor it from the first 2 terms, right? Not from the last term, from the first 2 terms. So like this, y equals negative 1/2 x squared. And what do I get if I factor a negative 1/2 from negative 1? Done? Okay. Thank you. See ya. I mean, in a way, it's like saying, what would you multiply times negative 1/2 to get negative 1? 2. So this is plus 2x. Okay, so that should work. I mean, in a way, what you're really doing is you're dividing negative 1 by negative 1/2, and you get 2. Okay, remember, how do we figure out the last term when you're completing the square? It's not new. Half of the middle coefficient squared, right? Half of 2 is 2 over 2 equals 1. 1 squared equals 1. Therefore, you've got to put a plus 1. Okay, but you can't just add something without doing something to cancel it out, right, to balance it. Okay, so in the end, I mean, the principle would be if you add 1 there, you're going to subtract a 1 there. But that's not really a 1. That's negative 1/2 times 1. So what are you going to have to do to balance it? You have to add 1/2, right? Since this equals negative 1/2, then that means here you add 1/2. So this is the new. It's negative 1/2 times x plus 1 squared plus 1. Now, is that in the form we need it to be so that we can find the the P and the focus and all that. I took half of 2 is 1. Oh, sorry, the 2x, I divided -1 by -1/2. Or, if, again, you could just imagine what would you multiply times -1/2 to get -1. Okay. So remember, we need this thing to be solved for the squared term. So you got to get everything else on the other side. So this is going to look like y minus 1 equals -1/2 x plus 1 squared. Multiply by -2, right? And that'll be -2 times y minus 1 equals x plus 1 squared. Okay, now we need to draw a picture. I need to draw a picture. Honestly, I have a hard time seeing it. I'll be able to see it if I could just like graph the vertex, understand which way it's opening. I'll know exactly how to finish this problem. What is the vertex? H is -1, right? And K is 1, right? The vertex is going to be HK is -1, 1. So, and is it going to open up, down, left, or right? It's y equals x squared, which tells you it's vertical, but it's got a negative. That means it's down. So if I'm going to draw a quick graph here, that'll be -1, +1. That's the vertex, and I know that it opens down. And I know that the focus is somewhere in here, right? I just got to figure out how far to go in there. So what am I supposed to use to figure out how far inside to place the focus? The P. Okay, well, where do I find the P? What does that number right there represent? 4P, right? If you go back to the 4P, it's not P, it's 4 times P, right? So we have to take that -2 and say 4P equals -2, so P equals -1/2. So we would expect the focus to be 1/2 down inside. So that means the focus is right there. What are the coordinates of that point? X equals -1, y equals 1/2. And it doesn't ask, but what would be the equation of the directrix? If the focus is 1/2 inside, then where do I find the directrix? Right, the directrix should be 1/2 on the other side. What is the equation of that line? What's that? It's a line. How do you make the equation of a line? Y equals 1.5, 3/2, 1.5, something like that. Okay. Ariana? Morgan? Okay. Find the standard form of an equation if you know the vertex and the focus. So what do you think I'm going to do first? Graph it. Graph it, okay? It'll make sense when you see the graph. So here we go. The vertex is at 2, 1, and the focus is at 2, 4. So 2, 1, 2, 4. So if the vertex is here and the focus is here, which direction does it open? Up, right? Because you know the parabola is going around it like that. Okay, so we need, now's the point. Write down the standard form for a parabola that opens up. That will be x minus h squared equals 4p y minus k. And what all do I need to plug into that again? H, K, and P. Okay, what is the HK? They told us right there. HK. What is the P? Okay, P is this distance right here. It's 3, right? From 2, 1 to 2, 4, P is 3. So that's what you have to plug in, right? This is x minus 2 equals 4 times 3 times y minus 1. And that could be simplified a little, right? You could say x minus 2 squared equals 12 times y minus 1. But you definitely wouldn't distribute the 12 or anything. That would not be the standard form anymore. Right? You want to be able to look at it and tell the vertex just by looking at it. Good, Andy. Okay, now parabolas are useful. Anybody have a satellite dish at home? I mean, satellite dishes are the shape of a parabola, or they have the characteristics of a parabola. Your headlights in your car, right? It's something that's called the reflective property for parabolas. So what you know with the reflective property is that, I mean, this is more drawn like to be your headlight. Your headlight has a parabolic back to it, and it's shiny. And then there's a light which is at the focus, and it's shining. And because of the reflective property of parabolas, it'll bounce off the back of the parabola and come out in parallel lines. So that's why the light is going in front. But even in terms, if I want to turn those arrows the other way, if you've got your satellite dish receiving a TV signal, right, then all of these rays are coming in. And, you know, it's the signal that you're getting from space isn't that strong. So the effect of this is the parallel lines come in and everything bounces to the focus, which is usually where you have a feeder horn, and the receiver is like right there. So the bigger your dish, the more you're concentrating and the better your signal should be. So everything bounces to there. Now I would say that a lot of them these days, they don't look like they're perfect parabolas when you look at them. So they've probably made the design a little more artsy or something, but it still has that property. The whole point of it is, wherever that is and whatever the exact shape is, it's making sure that as the parallel lines from space are coming in, that they're all being reflected exactly to where that feeder horn is and concentrating the signal. That all comes down to parabolas. Okay, so this is the only kind of problem that's kind of different that comes with this, and that has to do with tangent lines to a parabola. And there's a couple things that come out of this. One, it's a little bit of geometry that comes into play here. It's actually a little bit of physics, kind of like the balance of forces stuff. But it's actually quite a bit of how do you find a tangent line? And I'll tell you that the calculus teachers get kind of frustrated that, you know, in calculus, you learn a way to find the slope of this graph at any point. So when you find the tangent line, usually you're going to use a point slope form of a line. You're going to use y minus y1 equals m times x minus x1. So you're spending half of the time in calculus figuring out how to find that m. And then as long as you have 1 point on the shape or on the tangent line, then you just plug that in for the x1, y1. That's not supposed to be the hard part of the problem. But for a lot of students, maybe you just need to be reminded of it again. Right? How is it you find equation of a line if you know the slope and the point? And in this case, we're going to do it not with the slope and the point, but with 2 points. Because what can you do with 2 points? How can you come up with the equation of a line if you know 2 points? First, you find the slope, and then you do that, right? So it's actually a two-part process. Okay, so that's going back to straight line stuff. The other part of it is if you can imagine this line right here, which is the tangent line. Tangent lines touch at a point, and then they keep going in the same direction like that, right? If there's a line that's shining straight into that point like that. Does anybody play pool? You ever play pool, right? So what do you know when you bank a ball off of the rail, what do you know about the angle that it comes off on? It's the same, right? It's got to be exactly the same like that. So this equals this. The question would be, well, why is that? And you could, using a little Newtonian kind of physics, you could say this vector here, right, has components which are that direction and that direction. And then this vector has that direction and that direction. Unless there's something, friction or something, which there actually is, this vector is going to stay the same, and this one is completely reflected back the other way in an equal part. So this has to equal this has to equal this, which means these two have to be the same. That's kind of physics stuff with bodies in motion. Now, when it comes to light, electromagnetic radiation, does it work the same? And it does. I mean, that's also in a physics book. So we know that this angle here is the same as this angle here. They're labeling that with an alpha, right? So that's alpha and that's alpha. Now, since this line is straight up and down and this line is straight up and down, right? So these are the same, and these two angles are, where are we going? This angle and this angle, that's what you call corresponding angles in geometry. They all have to be the same. So if these two angles, these two are the same because of the physics of it. These two are the same because of corresponding angles. That means that these two angles in the triangle are the same. Well, what do you know about the sides in a triangle if two of the angles are equal? Then that means the opposite sides have to be equal. That has to be equal to that. So that's a property that holds with parabolas because of that reflective property. So the kind of problem that they will ask with that is like this. Find the tangent line at a point on a parabola. Okay, in this case, it says, find the equation of a tangent line to the parabola y equals x squared at the point 1, 1. Right? Here's y equals x squared. Here's the point 1, 1. The tangent line, pretty much like the last slide, is right there. Okay. So we know that the tangent line is going through the point 1, 1. Now remember, our goal is to come up with a tangent line. So what we need is 2 points on that line. Once we know 2 points on the line, then we can find the slope, plug it in. At this point, we don't know that point. We definitely know the 1, 1 because they told us that. But because these angles are the same, we know that this distance, which they're labeling as a D2, has to be equal to this distance, which they're labeling as a D1. Well, so if I know what this point is, 0, which is the focus, then I actually know these 2 points. I can find that distance using a distance formula. Okay, but I know how to find that point, right? Because this right here, y equals x squared, if I look at that as the standard form of a parabola, that's like saying x squared equals 4p times y. So what is the p in this problem, since it's actually 1y? P equals 1. Right? So for this one, we can tell that 4p equals 1. So p equals 1/4. That's how they got the coordinates to that point, 0, 1/4. Okay, so now use the distance formula. Let's find the d2, right? The distance. And then we will be able to go from that point to that point, going exactly that same distance down. And then we'll know 2 points on the same line, tangent line. So what's the distance? Remember the distance formula, if I have to remind you, is x2 minus x1 squared plus y2 minus y1 squared. In this problem, that will be the square root of 1 minus 0, which is 1 squared, plus 1 minus 1/4, which is 3/4 squared. So d equals the square root of, right, this term here, this 3/4 squared, that's 9/16. So let me make that 1 squared, into something with a denominator of 16. So that's 16 over 16. So this is the square root of 25 over 16, which is 5/4. Also known as 1 1/4. So that tells us this distance right here is 1 1/4. So this distance here has to be 1 1/4. So what's the coordinates at that point? If this distance is 1 1/4, you're starting at 0, 1/4. You're going straight down. What does that make this? -1. 0, -1. Okay, so now we've got 2 points. We're going to make a tangent line. 1, 1, and 0, -1. Okay, so the slope is 1 minus -1 divided by 1 minus 0, which is 2. And then you could use either one of these points in the point slope form. I'm going to go y minus 1 equals 2 times x minus 1. Solve for y. Y minus 1 equals 2x minus 2. Y equals 2x minus 1. So that's the equation of the tangent line. And does it look right? So y-intercept is -1. Slope is 2, which means up 2 over 1. Yeah, looks right. So, working? Everybody? Okay. That's it.